This is a play about photosynthesis. Photo what? Photosynthesis. Photo what? Photosynthesis. So what's that all about? A plant making sugar. A plant making sugar? Yes, so it can grow. Oh, so it can grow. Growing in the roots and growing in the stem and growing bigger branches and growing bigger fruit. Where does this happen? In the chloroplast. Where's the chloroplast? In the cell. Where's the cell? On the leaf. Where's the leaf? On the stem. The stem on a plant. The stem on a plant. A leaf on the stem. A leaf on the stem. The cell in the leaf. The cell in the leaf. The chloroplast in the cell. The chloroplast in the cell. The chloroplast. The chloroplast. The chloroplast.
It's a blast being a chloroplast.
It's a blast being a chloroplast.
It's a blast. Blast.
Blast
Being a chloroplast. There's not just one of us, you know. In each cell there's many.
And when we each do our part, we make enough food for the plant and enough oxygen for all you humans.
You can't see us by looking close at a leaf.
We're too small. Even if you put special glasses on, you still couldn't see us. We're too small. We're itty bitty. Even if you got out a hand magnifier and looked at a leaf, you'd see the surface and it would look cool. But you still couldn't see us. We're very petite.
You'd have to get a high-powered microscope and get that thin slice of wood.
And then you'd be able to see chloroplast in a cell.
And if you did, get that microscope out.
And look at that thin slice of wood. And you see rows and rows of cells. And in each cell, you'd see chloroplast. Happy chloroplast.
Having a blast.
Just being chloroplast.
You might say it's a happening place, because it's a place where stuff's happening.
Not just la 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 stuff.
What happens here is important, hugely important, vastly important,
Gigantically, abundantly, colossally.
important
To the plants.
and to everything on the planet Earth that breathes oxygen.
Say that again.
What happens here is hugely, vastly, gigantically, colossally important.
To the plant
And to everything on planet Earth that breathes oxygen. Hello, how are you today? I am a chloroplast, and I live inside this here plant cell. There are many other chloroplasts in the same cell, and they all do what I do, make food for this here plant. Yup, it all happens in here, inside this tiny space. And I know that you're wondering how, so let me show you. I'm fixing to start up a new batch right now anyway. Boy, they have a beautiful bright day outside today. Oh, look, here comes some light energy direct from the sun.
It sure is dark in here. I wonder what kind of place this is.
Hey, let go! Gotcha. Ha. What do you mean, let go? Nope, now you're looking for me.
What do you mean?
Well, you see, water will be entering the cell any second now.
Water? Where is it coming from? I entered this leaf about 3 feet off the ground. There's no water around.
The water is coming from the roots of the plant. The roots are pulling it up, out of the ground. And some of the roots reach down pretty deep to find it.
Okay, so water's coming. No, wait, that's not possible. How can water flow up? Gravity doesn't work that way.
Well, you see, the water travels in tubes called the xylem. And you're right, normally water doesn't travel up. But in a plant and even in a tree, the water is kind of sucked up the way soda is sucked up through a straw. It's called transpiration.
Here we are, boys.
Won't this be more water than we'll need?
Yes, but don't fret. The water that is not needed will evaporate to the surface of the leaf.
Why am I here? Somebody tell me what to do.
Okay, calm down. I need you to be patient. We're waiting for one more specialist to arrive, and then we can get this party started.
Exactly what kind of party will this be? I didn't bring a present or anything. Will you
This plant can't grow without you.
Say, we feel a draft all of a sudden. Close the window, pal.
There's no windows in our plant, so it can pass right through these cell walls. And that air you're feeling is just what we need next. Well, not all of it, just the carbon dioxide that is in it.
Say, mister, keep your paws off me.
Don't be afraid, I've been waiting for you.
Oh, I've heard of you. What do you want me to do?
You, my friend, are going to help make food for this here plant that we're inside of.
What's this?
I was light energy from the sun. But this here chloroplast trapped me as I entered this plant cell.
I was water mixed with minerals. I was pulled up from the roots and carried from the xylem.
So let me get this straight. The sun entered through the top of the leaf and was trapped by this here chloroplast. And the water traveled through an uploading tube called the xylem.
That's right. Say, how did you get in here?
You might say I slipped in through the back door.
You mean the underside of a leaf?
Exactly. There's little openings on the underside of the leaf called the stomata, and a whole lot of other air molecules came in with me. The other guys are seeing where they can go. Exactly, that's right. Now it's time for the water molecules to join hands with carbon dioxide molecules in the combination to produce food, also known as sugar.
Say, if they're combining to make sugar, what do you need me for? You didn't just capture me so I could watch, did you? Because I am really very busy. There are lots of dark places to explore, and there are lots of gloomy people that need me to help cheer up.
We need you very badly. In fact, you are like energy. You supply the water and the carbon dioxide with the energy needed to make all this happen.
Cool, now you're talking. I'm cool. You can't do this without me.
You can't do this without us. Get over yourself and let's get serious. We're ready.
Okay, light energy. You stay behind the water and the carbon dioxide. Ready, set, begin! Well, I'm glad you say it worked.
It worked alright, but who's this little guy hanging around by us?
Oh, I almost forgot. It says oxygen. Whenever a plant makes sugar, it also makes oxygen. So then when the sugar is sent to the parts of the plant, then some oxygen will be sent with it.
Oh, let me guess. Will the oxygen just leave the back door? You know, the stomata.
Exactly. Now it's time for you to be on your way, sugar.
Where exactly are we being sent and how will we get there?
You'll go wherever you're needed. Some of you may go to the stem of this plant, some of you will go to the fruit part of this plant, so where you'll remain in studs. But most of you will go to the roots, so that they can get bigger.
Sent to the roots? Isn't that a long way down? What do we do? Parachute?
No, silly, you ride the phloem. It's a tube like the xylem, except that it takes sugar to other places.
Okay, now that we become sugar, we need to ride the phloem wherever we're needed?
Yes, 3 now, on your way. There's light energy coming my way, and I'm fixing to lay my trap.
Remember when we talked about water leaving your plant through its stomata? Well, cottonwood trees lose 100 gallons of water every hour on hot desert days.
Each year, plants use more carbon in photosynthesis than is mined throughout the world.
1 million acres of corn can produce enough oxygen in 11 days to supply 10 million people with enough oxygen to breathe for a whole year.
If there was no more photosynthesis, there would be little food on Earth. Most organisms would disappear, and in time there would be no more oxygen in our atmosphere.
In 1774, Joseph Presley first documented the process of photosynthesis. That's 239 years ago.
The fossil fuels we use today all have their origins in photosynthesis. Coal was formed around 370 million years ago when large trees fell into swampland. The trees photosynthesized and made organic matter. Over millions of years, with high temperatures and great pressure, the organic matter changed into coal.
When does 6 plus 6 equal 7? When we're talking photosynthesis. 6 molecules of water plus 6 molecules of carbon dioxide, and of course light energy, equals 1 molecule of sugar and 6 molecules of oxygen. Thank you for coming to our play.